Today we want to discuss about our assignment 1. Our topic is material requirement planning part 1, MRP part 1. And this is our group member, myself, Kachin Mubrapan, and Muhammad Saleh, Jeffrey Zain, Suzana, Siti Shahira, and Aina Nabila. Okay, for question 1, um, Kachin Mubrapan, I want to present, explain about question 1, 1A. Use the information presented in figure 1 to do the following. A. Determine the quantities of B, C, D, E, and F needed to assemble 2x. Okay, this is a figure. It's figure 1. Okay, next, the solution. Okay, this is a solution 1A. Okay, we require 2x. 2x is require 2b. 2b, b, 2b times 2. 2 is from 2x equal 4. And then 2b require 3d. 3d times 4. 4 is from b equal 12. And e, 2b require 1e. 1e times 4. 4 is from b equal 4. And 3d require 4e. 4e times 12. 12 is from d equal 48. And 2x requires 1c. 1c times 2. 2 from 2x equal 2. And 1c require 2e. 2e times 2. 2 is from c equal 4. And f, 1c require 2f. 2f times 2. 2 from 2c equal 4. And 2x will require 4b, 2c, 12d, and 56e. 56e from 48 plus 4 and plus 4. Okay, and f, 4f. Okay, that's all for me. 1a. Okay, next. Muhammad Saleh.
Okay, I'm Muhammad Saleh Maulud, matrix number GS5X577. Okay, I will discuss about question 1B. The question is determine the quantities of these components that will be required to assemble 10X, taking into account the quantities on hand inventory of variation components. Components B on hand 3, C on hand 10, D on hand 15, E on hand 50. So next slide, solution on the next slide. So here we can see the product structure tree for X. They have three level. The level 0 is X, level 1 is B and C, level 2 is D, E and F, level 3 is E. So we can see from this product structure of 3, each X they require 2B and 1C. For on your left side, for B, each B they require 3D and 1E. On your right side, each C they require 2E and 2F C on C. All right. So for level 3 and lastly for each D they require So how to solve this problem? We start from X. Okay, from the product structure tree, we can see each X they require 2B. So in this in question, they need 10X. So we times B2, 2 times 10, we get 20. So bear in mind, we have quantity on hand 3. So B 20 minus 3, we get 17. Okay, for B, we get 17. So each B, they require 3D and 1E. So D, 3 times 17 refer to the B. So we get 15. So after get 15 on hand, we deduct 15. Component D, they have on hand 15. So we get 36. We get 36. All right. So next, we move to E. So each D, they need 4E. So 4E, 4 times 36, referring to the D. So we get 144. So deduct quantity on hand for E if 50. So we get 94. So for E on the right hand side for B2, E 1 times 17, we get 17, refer to the above 17 from the B. So for on the right hand side for C, for the component C, E is still C, we calculate 1 times 10, we get 10. Quantity on hand is 10, so will be 0. So E2 and F2, no need to solve this area. So the no lower level component required. So we no need to calculate this one. So for the answer, so that's given on hand inventory, and X will require. B is 17. C is 0. C is 0. D 36. E is 111. There is 94 from E4 and plus 217 from E on the right hand side of B. So F equal to 0 because there are no lower label required, component required. So that is the answer lah for 1B.
Okay, the next question is Jeffrey Z. Is it?
Susan first.
Susan. Susanna.
Yeah.
Okay.
Yeah. I'm Susanna. Matrix number GS 58535. I'm presenting question 2A. Okay, giving the following diagram for a product, determine the quantity of each component required to assemble 1 unit of the finished product. Okay. Figure diagram shows a finished product, product structure tree, where the components are listed by level. E is level 0. FGH is level 2, and FGH JDLJAD is level 2. So we see the solution for this one. To produce a unit of finished product E, we need 2 units of F, 1 unit of G, and 1 H. So by calculate the F is 2 units of F times 1 unit of E. so it's equal to 2. G, 1 unit of G to produce 1 unit of E times 1 equal to 1. To produce 1E, we need 1H, so 1 times 1 equal to 1. So we go down to level 2. To produce 1 unit of F, we use 2J and 4D. Okay. To produce G, we need 2L and 2J. And then we need 4A and 2D to produce 1H. Okay, so we need 2 units of J and 4D to produce 1F. To calculate J, we need to produce 1F. But we need 2F to produce 1E. So 2 times 2 equal to 4. So 2 is from J, and then 2 is from F, the number 2 from F. So 2 times 2 equal to 4. To calculate D, we need 4D to produce 1F. Okay. But we need 2F to produce 1. We need 4D to produce 1F. So D equal to 4 times 2 taken from 2 at the F, so equal to 8. To produce 1G, we need 2L and 2J. To calculate L equal to 2 units of L times 1 unit from G equal to 2. Okay. To calculate J, 2 units of J times 1 unit from G above equal to 2. Okay. To produce H, we need 4A and 2D. To calculate A, 4A times 1 we taken from H there equal to 4. Okay, because only 1 H is required to produce 1 E. Okay. So for D, 2 units of D times 1 taken from H equal to 2. Okay. Now we calculate the quantity of each component required to produce 1 E. So from the diagram, we can already calculate F equal to 2, G equal to 1, H equal to 1, J occur in 2 places. So 4 plus 2 equal to 6. For D, for L, okay, for L, the answer is 2. For A, the answer is 4 that we already calculate. For D, also occur in 2 places, which is 8 plus 2, because have 2 D there. Okay. So 8 plus 2 is equal to 10. That's all. Thank you.
Okay, for next is Jeffrey Zain. Okay.
Assalamualaikum and good evening to everyone. So I will present about the question 2B. Draw a tree diagram for the stapler Before that, my name is Jeffrey Zain Abdul Rashid, matric number GS 35889. So for the question B, draw a tree diagram for the stapler. If you can see the list, we got item and components. So for the stapler, become a level 0. So they need to produce stapler, they need components top assembly and base assembly. So top assembly and base assembly will become level 1. So for top assembly as a level 1, then its components cover, spring, and slide assembly. So that three components will become level 2. Okay, so at the level 2, they have cover, spring, and slide assembly. So at the slide assembly, then its component slide and also spring. So slide and springs will become L3. Okay, for the base assembly, for level 1, they need base, strike plate, and 2 rubber pad. Okay, so that 3 components will become L2. So the answer for the diagram, okay, the solution like this. So stapler will become X. So to produce stapler, we need 1 top assembly and 1 base assembly. Okay, for the top assembly A, to produce top assembly A, we need 1 cover B, 1 springs C, and also 1 slide assembly D. And to produce slide assembly D, we need side E and also spring C. For the level 1 base assembly K, to produce base assembly, we need base L, strike plate M, 1, and 2 rubber pad that we call N. So as a conclusion, to produce 1 stapler, we require 1 top assembly, 1 cover, 2 spring, because of at the level 2 we got spring C, and at the level 3 also we got spring C inside the side assembly D. Okay, so next is 1 base assembly, 1 component, base 1 component L, strike plate, rubber pad 2 component that we call N. So that's the solution. Thank you.
Okay, next.
Okay. Hello everyone, my name is Siti Shaira binti Suhaimi. I will be explaining on the first part of question 3, which is part A. For part A, the question is more on a description based product and type A. 2 Bs and 3 Cs are needed. For each B, 2 Cs and 5 Ds are. Moreover, each C is made up of 2 E's and 1 D's. By using this information, determine the quantities of B, C, D, and E needed to assemble 1A and draw the tree diagram as well. So according to this question, we are supposed to draw a tree diagram and determine the quantities of component that is needed to assemble 1A. So the advice to actually approach this question is when you see a description-based question, it is best to automatically jot down the components needed for each level. So for this question, as you can see in the tree diagram, level 0 is A. Level 2 is B and level 1 is B and C. Level 2 is C, D, and E. And level 3 is E only. So let's start from the first level. To produce 1A, you will need 2B and 3 Cs. To produce 2Bs, you will need 2 Cs and 5 Ds. And from that 5D, you will need 1E. However, for 3 Cs, you will need 1D and 2E to complete. So the way to do the calculation is, for the first level, 2B is needed to assemble 1A. So 2 times 1 would equal to 2. So for the second level, you can see that 2 Cs and 5 Ds are needed to calculate 1B. So 2 times 2 is equals to 4 because 2C is needed to calculate 1B. So if it's 2B, you will need 4 Cs. The same way of calculating proceeds to other components as well, which is 2 times 5 because it's 5 Ds equals to 10. And you can see from the E, because 5D is like D is actually needed for 10, which is why E 10 times with 1 is equals to 10. On the right hand side, 3 Cs is needed to calculate 1A. So 3 times 1 is equals to 3. 1D is needed to complete 3C. So 3 times 1 is equals to 3. 2E is needed to do C. So 3 times 2 is equals to 6. So from this tree diagram, you can see that the components needed to assemble 1A is B is equals to 2, C is equals to 4 plus 3, which is 7, because you are supposed to sum up all the C components. D is equals to 13 because 10 plus 3. E is equals to 16 because from B you can see E is equals to 10, and from the right side you can see E is equals to 6, which is why 10 plus 6 is equals to 16. So I will pass the presentation to Aina to explain the second part for question 3. Thank you.
Hi everyone, my name is Aina Nabila binti Zulkifli and I am going to present question 3B. So the question is, which is the IKEA table as shown in the figure below, construct a tree diagram and find the quantity of the components required to assemble the table below. So as we can see, that is a complete table and we are going to have to construct the tree diagram and also find the number of quantities of the components required to actually assemble the table shown in the diagram. So moving on to the solution. Okay, so this is a tree diagram. So how are we going to construct the tree diagram? So the table is the n item, and the components that are required to construct the table are in level 1, which is the tabletop and the legs. So the table is actually at level 0. So at level 1, we see the tabletop. So one tabletop, as we can see in the picture, is required to construct the table. So the formula is actually 1 times 1 equals to 1. And as you can see on the right side is the legs. So from the legs, we have two components that construct the legs, which is the screws and also the plate. So for the legs, there are 4 legs as shown in the diagram in the previous slide. So 1, one table and we have 4 legs. So 1 times 4 equals to 4. And moving on, from the legs, we have the components, which are the screws and the plates, and these are at level 2. So 5 screws is required to construct 1 leg. Therefore, we have 4 legs. So it's going to be 5 times 4 equals to 20. And lastly is the plate. So we have 1 plate for each legs. And we have 4 legs. So it's going to be 4 times 1 equals to 4. So this is the completed tree diagram. And from the tree diagram, we're actually just going to list out the components needed to assemble the table. So for one table, we require 1 tabletop, 4 legs, 20 screws, and also 4 plates. So we can actually use the same formula to construct maybe more than 1 table. For example, we have 2, 3, 4 table. Just going to use the same formula, construct the tree diagram, and also list out the components. So that's only for question 3B. Thank you.
Okay, thank you. Okay, that's all from our group 5. Thank you.